Hi there, Phil Simborg from the Backgammon Learning Center. Today I'm going to talk to you about colorless counting. And colorless counting is still very mysterious to a lot of people, and it's mysterious to a lot of people because it just doesn't seem to make sense. But I'm going to show you a quick guide to why it makes sense. Let's pretend you wanted to know the difference in pips here, or the pip count. What most people would do is they would count red or count blue. Any smart player would see instantly that the pip count difference is 1. Blue is 1 pip worse than red because this checker, instead of being here and being equal, is here. So it's pretty easy to see in a second that blue is losing by 1 pip. Well, let me show you something fascinating that Bob Urquhart came up with, and I helped him perfect it. If these checkers were not all the same color, it wouldn't matter if you had this configuration on both sides of the board. Let me show you. Let's swap 2 of red's checkers for 2 of blue's checkers, and you will see that the difference in pips is still 1. We just cost blue the same number of pips that we cost red by swapping them. So you could do the same thing here and find out, without counting all of blue's pips and all of red's pips, that the difference is 1. You match them up and ignore the colors. This is colorless counting. This idea of just matching them up when you have 15 checkers on each side, that was additional help that both Art Benjamin and Kit Woolsey independently came up with after I showed them colorless counting. They said, wait a second, we don't have to go through the entire colorless counting process if we have 15 checkers and 15 checkers. Now here's something else that's interesting. These checkers don't have to be exactly across from each other. Let's move these 2 checkers over here and these 2 checkers here. The difference is still 1, even though these aren't across. When I move these 2 checkers here, I cost red 4 pips. And when I move these 2 blue checkers from here to here, I cost blue 4 pips. So it still doesn't matter where they are. You can ignore the colors, and you could know that red is winning by 1 pip. Well, what if we had a more complex position and situation, something much more typical? Let's say that red is on his midpoint and blue is on his midpoint. This is a very, very common situation. Well, now I know there are 15 checkers on each side without having to count the checkers, because there's 4 blue checkers here and there's 4 red checkers here. So I match up the checkers going across, and I can see that the difference is still 1 pip. Now, most of the time, all we need to know is the difference. When there's a 1 pip difference, I know how to play my checkers. I know if I'm winning or losing the race. But what if I get into a cube situation where the difference is bigger and I need to know both the difference and the total pip count? Well, very simply, first you do this colorless counting method and come up with the difference, and then you count one side and you will know the total pip count. For example, in this time, you know the total pip count, and you'll know the difference once you have colorless counting. So with colorless counting, I instantly know the difference here is 1. What if I wanted to know what the total pip count was? Well, I know the difference is 1, then I can count either blue or red's pips, and I instantly know what the other side is. In this case, for example, I would count blue because it's very easy. When I know there's checkers across from each other, 2 checkers across from each other is 25. I used cluster counting that Jack Cassane developed. 2 checkers across from each other is 50. So these 2 checkers are 50. I know that 13 and 7 equals 20. So these 2 checkers and these 2 checkers is 40. 50 and 40 is 90. This is 4 pips. There's 94. This is 7 pips. That's 101. And 10 and 10 is 20. 122. Anyway, I did it a little carelessly, but you come up with 122. I forgot I added 1 wrong. So you got to get that right over the board too. But once you get 122 for blue, you know that red is 121. It works beautifully, and it saves a lot of time, and that's why colorless counting works. Now, what happens though when you don't have 15 and 15? Let's change the position to this and try and figure out the difference. Well, again, Kit and Art Benjamin found the shortcut. You, I instantly know that there's two checkers more on this side than this side because I have four blue checkers on this side and only two blue checkers here. So I know these last two checkers belong over, get counted on the blue side because they're, I only want to count the first 15 here and the other 15 all get counted for blue. So here's what you do. We know that these are all even inside. We know that red is ahead by 1 pip, is 1 pip ahead here, but he loses 22 pips here, so he's down 21 pips. But these two checkers is 26 pips. These are 26 pips that gets counted because it's a 13 point from red's perspective. So 21 pips less 26 pips means that there's a 5 pip difference, that the red side is winning by 5 pips, and sure enough, he's winning by 5 pips. Now, this doesn't tell me that the total pip count is 119, but at 5 pips, I have a pretty good feel for where I'm at in this race. So what if this checker is here? Now I instantly know that there are 3 red checkers over here, 4 red checkers over here, so only one of the checkers that's here gets counted on this side. So again, these checkers are even. Red's winning by 1 pip here. This is 22, so he's losing by 21 pips. This is 25. They're 2 across from each other is 25, so he must be winning by 4 pips. So here again, 4 pips. This is why colorless counting works. It's fast, it's easy to use, and it doesn't matter where the checkers are, as long as you have count 15 and 15, the first 15 for each side. Again, let's take these 2 red checkers. Right now, the difference is 4 pips. Put them anywhere. It's still going to be 4 pips. It doesn't matter where these checkers are. You can take these 2 checkers and put them anywhere, as long as you have the same configuration to match up. It's still going to be 4 pips. That's colorless counting. Now, if you want to go deeper into colorless counting, search colorless counting on YouTube, and you'll see that I have a couple of other videos that take it into greater detail on how to use it when you don't have anywhere near 15 and 15. You can still use colorless counting. And I also have another video called The Revolution in Pip Counting, where Jeremy Shearer, a really good friend of mine and one of my students, came up with some additional shortcuts for cluster counting and for bunching checkers together to count them faster, in addition to what Jack Kassane originally came up with. So all of these will help you. If you can count fast, if you can do it in a quick, fun way, you will count more often. The more often and the more accurately you count, the more you're going to do the counting, and everyone who knows this game can tell you that having a good, strong feel for the pip count is going to help your checker play and your cube play immensely, and it'll cause a lot less brain damage if you use these shortcuts. I hope you found this as fascinating as I did when we first discovered this, and when Kit and Art came up with this 15 checker shortcut. I think, and of course the original idea of the colorless counting guy, you got to give Bob Urquhart credit for that, and give me a little credit for helping Bob. Thanks for watching. Hope you enjoyed this, and hope you use colorless counting going forward. It's really fun.